This is problem 7-9. Here we're given allowable value is 8,000 psi. Okay, on this one it's a little different. You're not given y bar. You can tell right now that the center is not located up 1.5. So we need to find out what that distance is going to be. So what I would do in this case is draw a line straight out from here. I'm going to take all my y values, base all my y bars from there. I will start out saying that y bar is going to be, I'll do the whole entire rectangle first. So I'll do the area, which will be 3 times 4, 5. That's the area. And then the distance up would be 1.5 from there. And once I go along, I might as well just start adding in my area here, which will be 3 times 5. Now I'm going to minus this area here, which is going to be 3 by 2. And then to find its y bar, if I'm going up 2, I need to go up 1. And now I'm going to subtract the area of that, which is 2 times 3. I'll run that calculation and see what I get. I get 3 times 5 times 1.5 minus 6 divided by 15 minus 6. Gives us value of 1.8333, which means it's 1.833 up from here, or 1.1667 down from here. It makes no difference whatsoever. Now while we're at it, we'll go ahead and calculate a moment of inertia, which will equal to 1/12. I'm going to do this whole thing as 1, so that'd be base of 5 times 3 cubed. Now we use a parallel axis theorem. 5 times 3 is the area, times the distance from the new centroid, which will be 1.833, minus the distance from this bottom line to its centroid, which was 1.5. We will square that. Now we'll subtract out the other one, which will be minus 1/12, times its base, which is 3, times its height, which is 2. We will cube that. Now we'll subtract out. Let me get rid of this over here. I left this over here. Subtract out the area, which will be 3 times 2 times the distance it is from the new centroid, which we know was going to be 1.833 minus 1, and square that. When you do that, you will get a value of 6.75 inches to the fourth. Now to find your Q, you've got two ways to do the Q. I would do it the simple way. I'll draw a rough sketch of what's taking place here. You got a piece here, and you have a piece here, like this. Again, this is rough. Now above that, you could say, well, I also have the upper piece. It goes up kind of like this, and then back over like this, and then back down like this, and this kind of comes up like that, kind of comes over like this. Again, this is kind of rough. Alright, what I would do, it's going to be easier to do your Q value if you do just this piece down here and not this piece up here. So now we know that the distance from here up to here, when we calculate the centroid, was 1.833. We know these are 1 inches thick. So Q, in this case, will just be the area, which will be 1.833 times 1. Now the distance from here, from its centroid back to here, will be half this. We'll divide it by 2. And that would be the moment, that would be Q for this piece. We got 2 of these pieces, so just multiply this by 2. So what we really get is 1.833 squared. When we do that, that gives a value of 3.3 0.611 or something like that. Alright, now we just go back and we do VQ over IT because we have everything here. We know that the maximum allowable is going to equal to 8 times 10 to the third. So we set that equal to V. We take our Q value we have here, which is going to be 3.3611. We divide it by the moment inertia that we found, which is 6.75. And then our thickness is going to be 1 inch here, 1 inch here, which will give me a value of 2 inches. Okay, all you have to do now is solve for V. And when you do, you'll get V as 32132 pounds, or 32.1 kips. That's all there is to it. Not too bad. Again, the unique thing about this is you have to use parallel axis theorem to find the centroid, but everything else is identical. Okay?